Hey everyone, it's Mrs. Wallace. Just wanted to do this quick video so that everyone would have a chance to get a sense of some of the questions that we worked on in class on Friday. I know a lot of you were absent and some of you had questions about it. So we'll just kind of note some of the questions. I did number 7 in a separate video, so just look for that. This question is pretty straightforward. It really focuses on price discrimination. We're looking at a question where Amazon, the online bookseller, wants to increase its total revenue. That's a shocker, right? So Amazon's looking to make some more money. And one strategy is to offer a 10% discount on every book it sells. So the idea with the 10% discount is a 10%, reduction in price. And of course, the only reason that this would lead to an increase in total revenue would be if the books that it's selling are elastic. Amazon knows that customers can be divided into two distinct groups according to their responses to the discount. Okay, the accompanying table shows us these two groups. So we have Group A, we also have Group B, and our task is really to look at to what degree they are elastic, right? Well, we know for each one, Group A and Group B, the percentage change in price is going to be 10%, and it's going to be a decrease. Okay, so for both groups, the percentage change in price is going to be 10%, and that's what's going to be in the denominator. For the numerator, okay, we can kind of note that we might have for Group A, okay, Group A, we're going to see a change in sales, 1.65 million minus 1.55 million over 1.6, okay? So if we're looking at deciding whether or not Group A is going to be elastic or inelastic, I can see that the percentage for the percentage change in quantity is going to be 6.25%, okay? 6.25% over 10%. I can tell that the percentage change in price is greater than the percentage change in quantity, so Group A will be relatively inelastic, okay? Inelastic tells me if the price were to decrease 10%, total revenue will also decrease. Better off not to decrease the price for Group A. So I'm kind of looking at that being a really bad idea for Amazon. Let's give Group B a try, okay? For Group B, I am looking at the sales that are here on my schedule, okay? And I'm using the midpoint formula, but I'm kind of answering each of these questions, kind of at the same time. In this case, now I have 1.7 million minus 1.5 million all over 1.6 million if I'm using the midpoint formula. And in this case, I have a percent change that is going to be 12.5%, give or take. So with that 12.5% over 10%, I know that this is going to be elastic, okay? With an elastic good, if I lower the price, my total revenue should increase, okay? So some of you noted, well, it would be really, really good to give Group B the discount, okay? Because ultimately, Amazon would see a total revenue increase with Group B, but not with Group A. In fact, with Group A, because it's inelastic, there might be the possibility of actually raising the price on Group B. And some of you noted that, okay? So I hope that is clear, and we'll look at the next question. Okay, so for question number 2, this one was a little bit more of a thinking question, not so much numerical or graphing. We're looking for the PED, price elasticity of demand, and what is going to happen, in the scenario. So we're looking at SUVs, and all of these things are going to be affecting SUVs. What will happen? Will there be an increase, a decrease, or will we see things remain the same when there is a following event? Okay, so we're looking at what happens to price elasticity of demand, okay? This is really all about the nature of substitutes. The more we have substitutes for something, the more elastic the good is, okay? The more there's a substitute, the more likely when a price goes up, you're going to exchange that good for some other substitute. Other car manufacturers, such as General Motors, decide to make and sell SUVs. Well, now there's a lot more substitutes, okay? So this is going to increase PED, okay? Because there's just simply more substitutes. SUVs produced in foreign countries are banned from the American market. This is going to have the opposite effect. This is going to decrease PED simply because there are fewer substitutes. Due to ad campaigns, Americans believe that SUVs are much safer than than ordinary passenger cars, okay? If that's the case, okay, we are going to see that if there are ad campaigns and SUVs are much safer than ordinary passenger cars, people want SUVs, okay? Nothing else is really a substitute. No small car, nothing. We want an SUV, and that's it, because it's actually safer. If that was the case, we would see a decrease in the price elasticity of demand. And, this is kind of the reason for advertising, right? Advertising essentially makes the demand curve very inelastic. If it's very good advertising, that's what you want, at least people to perceive that there's no other substitutes for your product, whether you're selling lemonade or SUVs. If you can convince people that SUVs are much safer than other cars, you would have a more inelastic product. Okay, so elasticity decreases. D, during the time period over which you measure the elasticity, lengthens. Okay, so we know time period and elasticity have a relationship. Okay, during that time period, new models, four-wheel drive, cargo trucks, or whatever, there's going to be more substitutes in the long run. This is going to increase PED. Okay, so price elasticity of demand increases over the greater and greater time because we have new models. Okay, so always look at what is the scenario and how much does this help me understand how many substitutes there are for the product that I'm interested in. For the third question, this is the one that was perhaps a little bit most ambiguous. So first of all, here we're dealing with price elasticity of supply. Okay, remember there's a direct relationship. If there is a increase in price, right, we know that the quantity supplied, there's also going to be an increase. If the price decreases, quantity supplied will decrease, and supply can be either perfectly inelastic or perfectly elastic, or somewhere where it's relatively elastic, okay, or relatively inelastic if it's a little bit steeper. Elasticity of supply is generally something that we're looking at from the producer's perspective. How likely is it when the price increases that they can actually make greater quantities, okay? So the very first one, an increase in demand this summer for luxury cruises leads to a huge jump in sales, okay, in the price of a cabin on the Queen Mary 2. Well, something we know about cruise ships is they have a set number of cabins, so we're going to be seeing a perfectly inelastic curve for supply. This would be the same for, say, like seats in the BCA auditorium. You could have lots of people or no people interested in coming to see a concert in the BCA auditorium, but at the end of the day, there's only so many seats in the BCA auditorium. Now, maybe in the very long run, if we wanted to knock out all the seats in the BCA auditorium and increase the quantity of seats and make everybody's seats smaller or something like that, or do some construction, we probably could, okay? And the same thing with maybe, so in the long run, maybe the quantity of supplied cabins in this cruise ship could be a little bit more elastic. But an increase in demand this summer, right, we're looking at a situation like this. The increase in demand is happening, but there's only, so much supply. The quantity supplied is completely fixed, okay? We would really call this fixed supply, just like apartment buildings or other things. For part B, the price of a kilowatt of electricity is the same during periods of high electricity demand as well as low electricity demand, okay? In this case, we have perfectly elastic supply, okay? Here's the price of the electricity, and it doesn't really matter. Let's say it's $100, during a certain time frame. Now the demand is increasing, okay? The price of the electricity is really the same. The supply of electricity would be constant and would be a horizontal line, okay? So we don't have any price changes at all as a result of the changes in demand. And then for C, fewer people want to fly during February than any other month. Airlines cancel 10% of their flights, okay? So this is a quantity thing. So percentage change in quantity is 10%. Percentage change in price is 20%, okay? We know that this is something that is going to be relatively inelastic, okay? Why? It's not perfectly inelastic because we don't have a coefficient of 0, but it's relatively inelastic because we have a coefficient that is going to be less than 1, okay? The owners of vacation homes in Maine rent them out during the summer. Due to the soft economy this year, 30% decline in price, okay? So we get a sense of what the denominator is going to be, leads to more than half of homeowners are occupying the vacation homes themselves, okay? So we might have half, okay, of the, homes that are not available anymore. So the supply, the quantity supplied has decreased 50%, and the price has decreased 30%. This is going to be elastic, okay, because the percentage change in quantity supplied is greater than the percentage change in price, okay? So if you were graphing this would be a typical maybe elastic curve, maybe something like this. Of course, it would be a range, so between two prices. The same thing here, something in an inelastic range. If you were asked to draw a curve, you might draw something a little bit steeper, or it could be inelastic in that range of the supply curve. Okay, this one many of you seem to be pretty comfortable with. We are looking at a situation where the Honda Civic, okay, which is a small car, right? Here's our, Honda Civic. I can't draw, right? But here it is. It's cruising around. That's my car. Equals car. Woo! The Honda Civic is looks like it's rising, right? It's rising by 7.1%. The sales are, okay? So it is an increase in 7.1%, okay, in the quantity. Over the same period, right, the average price of regular gasoline, and this is going to be a cross price elasticity because now I'm looking at 7.1%. It's an increase in quantity demanded, right? So there's greater sales. This is an increase in quantity demanded, but this is as a result of a price change, right, of gasoline, not a price change of cars. So this is going to be cross-price elasticity. Okay, and the percentage change in price is going to be 257 minus 227 over, let's see what our midpoint formula is. It is going to be 2. Okay, I am just going to put here 257 plus 227 over 2. I am going to do this on my calculator, and I am going to get, let's see, calculator, what do you say? It is going to be 15. Nope, sorry. Okay, 0.30 over 2.42, okay, 12.4. All right, so it is, first of all, it is, you're looking at the percentage change in price of gasoline at 12.4%. So as a result of the increase in price, okay, so this was an increase. This is the 12.4%, okay, was a percentage change in price of gas, okay, and the increase in sales was 7.1% of quantity demanded of the cars, okay. So I can tell that this is actually going to be inelastic, but more importantly, it is going to ask, are these complements or substitutes? And because the increase in the price of gas is actually going to increase the quantity demanded for cars, I know that these are substitutes, okay? And that might feel weird because a lot of times we would think that gas and cars are complements, right? And to some degree they are. Gasoline is much cheaper. That might bode well for the way in which we might drive more because gas is cheaper. If gas is more expensive, maybe we all drive less. So whatever car you own, certainly you can look at the way in which those two goods might move together, and they might affect driver behavior or the sales of automobiles. The one unique thing here is that we have the Honda Civic, okay, which happens to be a little car. It is not an SUV. It is something something small, okay? And because it is something really, really small, it might be if the price of gas actually increases from 227 to 257, that's a significant price hike of 12.4%. We might actually see people getting rid of some of their SUVs and buying Honda Civics. So the reason that these goods are substitutes has to do with the fact that as gas is increasing and increasing and increasing, people are looking at substituting their particular, Honda Civic maybe with something else. So they are actually substitutes. They have a relationship as substitutes. Okay, so I hope that that helps, and we'll look at the next one, and then there's one more after that, and that's the final questions. Okay. Okay, this question is actually pretty straightforward. All taxes impose excise taxes on gasoline, which is true. In fact, New Jersey just increased theirs. According to data from the Federal Highway Administration, the state of California imposes an excise tax of 18 cents per gallon on gasoline, and we know that sales in 2005 totaled 15.6 billion gallons. So one question that we can look at is, what was California's tax revenue from the gasoline excise tax? So revenue is always going to be the price times the quantity. In this case, because we're looking at the revenue from the tax, we know that there was 15.6 billion gallons bought in California in 2005, and each one of those was taxed at a rate of 18 cents, right? So you're simply just going to multiply the 15.6 billion times 18, and we would get the tax revenue. Tax revenue should equal 2.8 billion, okay? And that's a significant, kind of chunk of change, right? Because of the quantity of gas. Now, if this tax, if we look at, California doubled the excise tax, so instead of making it 18 cents, made it whatever, 36 cents, that would be not going to double the tax revenue, okay? And why is that the case? Because usually when we have a tax increase, you're going to see a shift leftward of the supply curve, but remember that as soon as we see a shift leftward of the supply curve, you would have lower quantity. So even though the tax might actually double, the quantity here, the 12.6 billion, might actually lower. So does that mean that this whole thing is going to double? Not the case at all. Okay. In fact, we don't know exactly what would happen unless we had the elasticity coefficient if they raised the price of the tax up to 36 cents. But quantity would likely be affected, and we'd probably see a lower number than 15.6. And if that was the case, then we would not double the tax. We might have more revenue with the price increase, but we don't necessarily know that we would have double, right? The exception would be if you had a situation where you had perfectly inelastic demand, because in that case, you would have a you would have a situation where perhaps you could double, if it was perfectly inelastic and every single one of these gas gallons was still bought and sold regardless of a price increase. Okay, and last but not least, the state needs to raise money. Right now we do. And the governor has a choice of imposing an excise tax of the same amount on one or of two previously untaxed goods. Okay, so we can either do meals or gasoline. Both the demand for and the supply of restaurant meals are more elastic than the demand for and the supply of gasoline. If the government wants to minimize the dead weight loss caused by the tax, which good should be taxed. And in this case, all we have to do is just kind of do some graphing, right? So one thing we might want to graph is the restaurant meal. Okay, and then we'll also graph the gasoline. If we graph the restaurant meal, we are told that demand is fairly elastic. Let's draw something relatively flat. Supply is also kind of, I've got a pretty typical supply curve, but let's imagine now that we have a supply curve plus the tax, okay? And I'm in a situation where this is my new consumer price, this is my producer price, here is my tax, okay? And in red, we will put the deadweight loss, okay? As a result of the tax, this is our deadweight loss. It's fairly sizable. This was the quantity that was allocatively efficient. This is the new quantity, okay, with the tax. If we go to the gas, okay, so let's kind of graph the gas. we had a situation, sorry, my graph is not that, straight, where demand was very steep, supply was also very steep. So let's imagine that now we put a tax on this, okay? In this case, now we have a new consumer price, okay? This is the price for the consumer, and this would be the supplier's new price. This is the price for the producer, okay? This whole thing here would be the government revenue of the tax, okay? And I'll put in red the size of the deadweight loss, okay? So something that you can notice here is we have a much greater gap in the quantity as a result of the tax, okay? This is because both things are relatively inelastic here. We are likely to see less deadweight loss because we have less of a gap between the allocatively efficient quantity and the quantity that is now going to be produced. In the case of the restaurant meals, and what if we were trying to limit deadweight loss, the gas is what would actually be taxed. It's much more inelastic. People tend to buy it regardless of price increases. In the case of the restaurant meals, we see quite a few people deciding not to go for that steak dinner. There's a huge gap between the quantity that is allocatively efficient and the quantity for the tax. We have a much bigger deadweight loss, and we can suggest that this should not be taxed. It is probably much more elastic, and this is our flatter supply and demand curves, okay? I hope that helps everyone. Have a good rest of the night. We'll see you in class.